How can GPS make our work processes more productive? Well, our next guest is going to be talking about that because he provides positioning solutions that enable professionals in engineering and construction, surveying, agriculture, fleet management. I mean, he runs the gamut of all kinds of cool things, all kinds of field services, for example, helping them to be more productive by actually revolutionizing their work, and he can do just that. Director of Marketing for the Construction Division from Trimble is Alan Sharp. Alan, welcome into Tomorrow. How you doing?
Yeah, very good, thank you.
We're delighted to have you with us. When we say that Trimble provides positioning solutions, I don't think you mean go stand over there, you know, and there's a solution.
Not quite.
But you mean doing some pretty unique things. Tell me what's happening there.
Okay, so positioning solutions in our world basically means we take traditional positioning technology such as GPS or optical positioning or laser leveling type equipment, and we put it into an environment which is used by a specific type of customer group, which could be agriculture, it could be construction. I happen to be working in the construction group. And the technologies we take those along with field computing technology and application software to build a turnkey solution that allows you to do something that you could do before, but more productively, more efficiently, saving materials as you go. So
is this where, like, we would see a surveyor out in the middle of a field, but he's got a GPS thing on top?
So traditionally, the surveyor is the kind of guy that we've always dealt with in the past. One of the things we're doing these days in the construction world, though, is we're putting that kind of technology onto large earth-moving machines and automating the process of construction on those machines and eliminating a lot of the work that a traditional surveyor has always done.
So these big earth movers then are using those GPS coordinates to be really pinpointed in proper grading of the area and so forth. I'll bet we save a whole lot of not only earth, but do the right thing and not have to be just moving dirt somewhere that it could be better used.
That's right. So what we do is we take the positioning technology along with other sensors on the machine to control for things like the long slope and the cross slope of the machine, the rotation of a blade. And with all those technologies combined, we can then determine exactly where the tips of the blade should be in real time. And we compare that with the digital design that's been provided by the engineer and automate the hydraulics on the machine to control the blade to grade. So we're in the software world, we talk about 3D visualization. I think in the construction world, we're talking about 3D realization. So we actually convert the digital design into a three-dimensional model that actually people can drive on.
I like that line, 3D realization, because that's actually what's happening. And it sounds like you're bringing not only the surveyors and engineers involved, but the bulldozer operators and everybody else really into tomorrow with the latest technology that they got to be loving, how precise now their job can be. That's
what we're doing. I mean, we have a mixture of operators in the world that actually use this type of technology. Obviously, the new younger generation operators are coming in with the PlayStation generation. Yeah. They're all used to video games and that kind of thing. So running a control box or a computer on the cab, automating the controls on the machine is something they're quite familiar with.
Good point. And especially with the younger group that say, hey, come on, the technology is available. Let's use it. And you are helping them do just that.
Exactly right. Yeah.
Oh, I'm loving that. Now, how does the data get from the guy in the field with the GPS unit on top of his survey unit to the guy running the bulldozer?
So basically what we do is the digital design starts life in the engineering office. So people using Autodesk products, for instance, are developing digital designs of a project. They'll visualize and validate, present them to the client, get approval, then it's let out to the contractor. At that point, the contractor takes that same digital model, converts it into something that the user can use on the machine, and then they send it out to the machines either via a simple data card or a USB stick, or over the air, over wireless technology directly to the machine, which on the bigger project saves them a lot of time and money in terms of travel time and cost.
Oh, I would imagine. So the back end where Autodesk is doing the heavy lifting, if you will, for the bulldozer operator even, making all this happen and putting it into information that is easily followed and easily dealt with and not making mistakes out on the field.
Exactly right. I mean, we eliminate, through the use of GPS, traditionally in the past people used surveying equipment to put in stakes in the ground, which the bulldozer operator would look out of the cab window and work out where he needed to put the blade in real time as he was driving the machine. Yeah. These days he doesn't have to worry about looking at stakes. The surveyors don't have to put any stakes in the ground. The machine just drives in the right place, and as long as it's in the right place, the ground will get put in the right place.
So you're saving on lumber too.
Saving a lot on lumber. Some projects it's hundreds of thousands of dollars on lumber alone.
That's another very valid point. And I can see the increase in productivity with tools like this. Now that has to be for the end user customer, the construction folks in the field, a dramatic improvement.
Exactly. I mean, if you look at the machine manufacturers themselves, people like Caterpillar, Komatsu, they'll go through several years of development to develop a brand new machine with new engines, new traction control, new tracks, just to save 1 or 2% in production on the machine itself. they put a GPS system on the machine, in proof we're actually showing 30 to 40% increase in production, which saves number of passes, it saves material, it saves fuel cost, which saves the environment through carbon emissions, and today in some states it's very important. It also saves, operator fatigue. It also saves, means that inexperienced operators can actually run a machine as productively as a very advanced operator. So you get savings right across the board, which turns into real value for the client.
Oh, for sure. Imagine, and time saving too. And now all of a sudden a construction project that is, everybody's complaining about is taking too long, is now being cut dramatically time-wise.
Yeah,
so it's a win-win-win everywhere you look.
Yeah, on 1 to 2 year projects, people can save up to 6 months in time because they're using machine control on projects.
Awesome. You have got to check out what Alan and his team are working on. Visit his site, Trimble.com, Trimble.com. We'll link you there, too, of course. Alan, you got some really cool stuff happening, and I'm glad we had a chance to talk to you here at Autodesk University.
Thanks very much for inviting us.
It's our pleasure. Visit intotomorrow.com. We'll have links to all of our guests and, of course, videos. Watch videos of the interviews, highlight video from here at Autodesk University, and lots more. Meantime, I'm Dave Graveline. This is Into Tomorrow. Don't go away. We continue on the Advanced Media Network.